In the previous video, we have learned how to use a comparison test to examine the convergence or divergence of a given series. In this video also, we will continue with the same topic, that is, we are going to use a comparison test to examine the convergence or divergence of the given series. Let's do the first one. What is un from there? It is 1 upon twice n minus 1 into twice n. Now for large values of n, this one is nearly the same as 1 upon 2 into 2, 4, and then n square. Okay, so from here, what is Vn? 1 upon n square. Now divide un by Vn. So we have 1 upon twice n minus 1 into 2n. Divide by Vn, that is by this one, we have n square. Okay, and then take the limit. N tends to infinity, un by Vn. Here we have n square by twice n minus 1 into 2n. From the denominator, we take common by n. So we have n into 2 minus 1 upon n into 2n. So n square get cancelled. Now, as we put n by infinity, we replace n by infinity, we have 1 upon infinity to be 0. So 2 minus 0 is 2, and 2 into 2 is 4. So the answer is 4. This one is not equal to 0, and it is finite. Okay, now un will converge if vn converge, otherwise it will diverge. So we take vn. What is vn? 1 upon n square. Now this one is a p series with p equal to 2, which is greater than 1. Since p is greater than 1, this series converges. Now if vn converges, un also converges. This is the comparison test. Okay, so let's do the second one. From the second one, what is un? Un is n plus 1 by n cube. Okay, this one is nearly the same as n upon n cube, which is equal to 1 upon n square. So find vn first. It is 1 upon n square. Now take the limit n tends to infinity, un by vn. What is un? N plus 1 by n cube. Divide by vn, that means by 1 upon n square. So when it comes to the numerator, it comes as n square. Okay, now here we have common by n into 1 plus 1 upon n cube into n square. So from the numerator we have n cube. Then n cube gets cancelled with n cube from the denominator. Now as n tends to infinity, 1 plus 1 by infinity is 1. This one is not equal to 0, and it is finite. Now take the series Vn. Summation 1 upon n squared. This is a p series with p equal to 2, which is greater than 1. Since p is greater than 1, this series converges. If Vn converges, then summation un, which is summation n plus 1 by n cube, also converges by the comparison test. We do the third one. Un from there is 1 upon twice n minus 1 into 2n plus 1. Okay, so this one is nearly the same as 1 upon 4n square. And we can find Vn from here, that is 1 upon n square. Okay, So take the limit n tends to infinity un by vn, or un is 1 upon twice n minus 1 into 2n plus 1. So into n square we divide by vn, that is by 1 upon n square. Limit n tends to infinity. From the denominator we take common by n. We have 2 minus 1 upon n. Here also n, 2 plus 1 upon n. So n square get cancelled. Now if we put n by infinity, we get 1 upon infinity, which is 0. 0. So we are left with 2 minus 0 into 2 plus 0, which is 4. So 1 upon 4. This one is not equal to 0 and it is finite. So now take Vn, summation 1 upon n square. This one is again a p series with p equal to 2, which is greater than 1. Since p is greater than 1, this series converges. So if Vn converges, Un also converges by the comparison test. So this is how we use the comparison test to check whether a given series is convergent or divergent. Okay.